Ciao friends, and welcome to a new video from SQL BI. In this video, I want to talk about composite models, but specifically I want to introduce a very important concept in composite model, that is the difference between wholesale execution of a query and retail execution of a query. Whenever you create a composite model, you have two different data islands. You have the vertical continent, and you have a direct query analysis services data island that contains the data of the remote model. And depending on where the execution happens, we say that the execution is either wholesale or retail. Let me show you this a bit better with the whiteboard. Let's pretend that you create just a live connection to a remote model. When you create a live connection with the model, all the queries are executed by the remote model. So you have a data model that contains several pieces of information, and you have your report here that sends query to the remote model, and everything works fine. Things are quite different whenever you start creating a composite model, because in a composite model you still have the direct query island that contains the data in the remote model, but you also have the vertipack continent. So you have a data model with vertipack that is local to your own data model. And at this point, whenever you execute the query can be executed entirely here in the direct query island. And if that is the case, we say that the query is wholesale. So a query that only touches the direct query island, we call it an wholesale query because it will be sent to the server that executes the queries in its entirety. But sometimes you need to scan tables that are in the direct query island, and also some tables that are in the local vertical continent. If that is the case, the query needs to be executed partially from the local engine, partially from the remote engine, and then the results needs to be combined together. And if that is the case, we call this kind of query a retail query. So the difference between wholesale and retail is in where the data is. If the data is entirely in the remote model, then it's wholesale. If the data is also in the local model and they need to be merged together, then it's a retail query. And it's important to understand the difference because for some specific calculations, the requirement is that the calculation needs to be wholesale, for example, for calculated columns. And there are differences in the usage of all selected and in composite models, depending on whether the query is wholesale or retail. In this video, we are only going to introduce the difference between wholesale and retail, and we will talk about all selected and composite models in different videos. So let's jump to the computer and let's try to understand a bit better with some demos. I have here a Power BI file just opened, and right now it does not contain any data. But I'm going to connect it to a Power BI dataset in the cloud that only contains the Contoso model. This dataset does not contain anything really fancy, just the Contoso model. Right now I created a live connection, and I can already make it work. I can just take the sales amount and then slice it by product brand or by category. I just make it in a matrix and with a bit larger font because I cannot read at that size. So we do have the global font size. Let's go for 20. Okay, the query that runs and produces this result right now is executed on the remote model because there is no other model. I have a live connection with a remote model. But you see that I have the option of making changes to the model. I can go here, let me see if it's visible, and I can click on make changes to this model. When that happens, the engine creates a local vertical continent and uses the remote model like a direct query connection. So at that point, we will have two islands, the local island and the remote island. And this all happens as soon as I click on make changes to this model. Just click on add the local data model. The engine recreates basically the data model. And now I end up having two models. Right now, this query is still working just fine, and it is a wholesale query. What I gain is the capability of creating new columns. For example, I can go here on sales and create a new column inside the sales table. Now, what happens when I create a calculated column? Where is the column being stored? Actually, calculated columns are not computed and stored anywhere. They are just sent to the server as wholesale queries. Let's pretend, for example, that we want to analyze the discount percentage of our sales. What I can do is create a first column in the sales table that contains the discount percentage. So let me increase the font a bit. We create a discount percentage by just dividing the sales unit price minus the sales net price, that is the discount, and I divide this value by the sales unit price. This produces the discount percentage as a calculated column. Then, based on this column, I can create a new column that groups the categories, the discount percentage, in different buckets. Because if I just use this column as it is right now, let's take the discount percentage and place it on the rows, you see that I have a lot of values and it's nearly impossible to understand or to gather any kind of insight. So what I want to do is create buckets of discount percentage. And I can do that with a new column that I call discount category, where I just compute the, well, I can use a switch, and then depending switch on true, if the discount percentage is less or is equal to 0, then it's no discount. And then using the same pattern but with different boundaries, I can create different categories. So for example, if it's less or equal than 0.05, then it's a low discount. If it is less or equal than, let's say, 10%, so 0.10, then it's a medium discount. Otherwise, it's a high discount. So right now I created two calculated columns in the sales table. And again, the question is, where is this column computed? I have a syntax error. Oh, actually the syntax error is that I'm missing a double quotes there. So I can now take the discount category and slice by the sales amount. You see that everything is working just fine. High discount, low, medium, no discount. Actually, that is not really nice because the sorting doesn't work the right way. So I can take the discount category, create a discount category sort column. Let's do that. Let's call it discount category sort. No discount, we sort it at 0. Low discount is 1, medium discount is 2, otherwise it goes to 3. So I now have 3 calculated columns in the sales table, and I can use discount sort to sort discount category. So discount category, we sort it by discount category sort. And now I have no discount, low discount, medium discount, and high discount. The interesting question we want to answer is, where is this column being stored? Right now, we do have the local storage, the vertical continent, which is empty right now because we have not created any tables. And we have tables in the remote model. Where is my column being stored? The truth is that this column is not being stored anywhere. The execution of the query that produces the visual is entirely wholesale. It is sent to the server, and then the server executes the code of the calculated column every time you run the query. Let me show you that with Performance Analyzer. We can enable Performance Analyzer. No, it's under View, Performance Analyzer. We start recording, we refresh the visual, and now we have here the code of the matrix. I can copy the query, and then we inspect it using DAX Studio. So let me open DAX Studio and place it in the right monitor. Okay, and now we can copy the content of the query. Please note that as soon as you do that, you have the option of choosing the DAX query only or both DAX and direct query, because the engine detected that there is a DAX query, the local one, and also the direct query DAX query. Let's take a look at the content of this query. At the beginning, we have the query that is executed by the local engine. And despite looking complex, it is actually quite simple. We can just make it a bit simpler by removing the useless stuff. Okay, and basically this is the query that is being executed. Let me also format it. It's summarizing column by discount category and discount category sort, and it's computing the sales amount. This is the query executed by the local engine. And this query is translated into a different query that I have here. So let me copy in a new window. I didn't copy it, probably. Oh no, I did, but the engine detected that. I want everything because I want to format this code. And you see that the query executed to the remote engine contains the definition of discount category, the definition of discount category sort, and the definition of discount percentage. The three columns that are created as calculated columns in the local model are actually sent as part of the direct query every time you run the code. And then we have a summarized column that groups by the columns which are prefixed with ASDQ, which are created on the fly during the query. We actually have one query to compute the grand total. No, we actually have a single query that computes everything. Now, this is an example of an wholesale query, a query that is executed entirely by the server. Even though you create calculated columns in the local model or calculated columns in the remote tables, but that are defined in the local model, these columns are sent as part of a single query. Wholesale queries are quite simple in their execution because they only are a DAX query executed by the remote server, and the local engine only needs to retrieve the result and publish it on the visual or do whatever is needed with the result computed by the remote server. Things are not so easy when you start making things a bit harder, but we will see that later. For now, I want to show you that wholesale is a requirement for calculated columns because calculated columns are not computed locally. Therefore, a calculated column needs to be computed by the remote server. If you write code in a calculated column that tries to access local tables, the calculated column simply cannot be created. And in order to show you this, I want to change a bit our code. Let me explain this with a demo. Let's get rid of performance analyzer and let me show you the code of discount category. There's nothing bad with this code apart from the fact that the boundaries of the calculation, they are stored inside the formula. This is not really data driven. We can do it better. For example, we might want to create a table that contains the discount categories and then use that table so that changing the table gives us the option of creating different categories. So we can just generate a new table. Let me go to modeling and then we create a new table. And we can actually just create it with DAX. It's probably better if I copy the code of the column from here, just to avoid messing up with the values. So modeling and then new table. Okay, we call the table discount category. And the table just does, it's a data table. No, we can make it just a constant table where we need a code, let's say 0, and then the description, no discount, and the boundary 0. And now that we have the first row, we can create the next one. 1, 2, 3. We have low discount, that is 0.05, 0.05. then we have medium discount that says 0.10, and finally no discount, and we need a boundary, so let's place a large number. Actually, the last line is high discount, not no discount. Now, this table generates a table where the columns are named value 1, value 2, value 0, value 3, so we want to rename them, and we can do a select columns out of it. The first column, we call it the discount code, which is value 1. The second column, we call it discount category, and that is what is called here value 2. And I hit enter a bit too early. And the last one is the discount percentage, which is value 3. Okay, now I have a table that contains the same boundaries that I created in the formula, but now it's completely data-driven. So let me look at the content of the table, and you see that we have discount code, discount category, and discount percentage. The next step is to create a calculated column in sales that computes the discount code so that we can create a relationship between discount code and the column that we might create in the sales table. We can try to do that, but as you are going to see, this is not going to work. The code of such a column would need to retrieve from the discount category table the correct value. So what we can do is, let me see the code that I wrote in the article, so we make it the same. Okay, we can create a discount category. Let's call it data driven, because now this version of the code will be entirely data driven. In order to make it work, I need a discount percentage variable where I can just store the sales discount percentage column that I created earlier. Then I can find the higher categories by filtering all the categories, filter discount category, and here is the first detail. If I try to write discount category, you see that IntelliSense does not let me do that. I can force it, discount category. Let's pretend this is a bug in the IntelliSense, where discount category, discount percentage, actually I have the space, is a higher category, so greater or equal than the variable discount percentage. And once I have this filter that retrieves the table with all the different categories, I find the minimum. So I can compute the result as the min x out of higher categories of discount. I need to write it down, discount category, discount code, return result. Now, this code would work if I had the option of accessing discount category. But the problem of this code is that this code is trying to access discount category, and discount category is in the local vertical continent. Being a calculated column, the code of the calculated column needs to be wholesale, and it cannot be executed. It cannot access local objects. Besides, if I try to hit enter, I obtain an error. And the error this time is kind of simple to understand. It says the column discount category data driven cannot be pushed to the remote server. Here is the code. It cannot be pushed to the remote data source. Therefore, it cannot be used in this scenario. The thing is, this code cannot be executed by the remote engine because the remote engine has no clue about the very existence of our discount category table. There is a table we created on the local engine. Therefore, the execution of this column cannot happen wholesale. So how do we solve the scenario when we want to create the discount category data-driven? We cannot rely on calculated columns. What we need to do is create a table in the local model, and then create a relationship between a calculated column in sales and this table. But the relationship cannot be stored in code, in DAX code inside the calculated column. It needs to be stored as a regular relationship. So the next step is that we create a table in the local model that contains all the possible values of the discount percentage value with the category that we assign to this value. And then we create the relationship. So let's do that one step at a time. This discount category data driven is actually useless because it simply does not work. So let me delete it because we don't need it anymore. So what we want to do is create a table that contains all the different discount percentages. And it's easier if we do that with DAX Studio. So let's create a new window connected to the same model. We want to retrieve all the values of the discount percentage. So we start with all no blank row of sales discount percentage. And that retrieves all the different values of just the discount percentage column. Then we want to assign to each discount percentage its own category. So we need to do generate because we want to add multiple columns. And we first create a variable, let's call it discount percentage, which is just the value of sales discount percentage. Then we create a second variable that contains all the categories which are higher, the same as we did previously, higher categories. And we use filter over discount category, where the discount category discount percentage is greater or equal than the discount percentage. Return. Let me show you what happens if I just retrieve higher categories. As a result, for each discount percentage, I will have that closes generate. Let me check. Yes, it closes generate. I will have for each discount percentage all the categories which are higher. So that is not yet the result that I want. You see that for 0% I have both no discount and low discount. That is not what I want. I want to have only for 0% no discount. So I just retrieve out of higher categories the first one. So discount category. I just take the top n out of the higher categories. Top n 1 out of higher categories, ordered by discount category discount percentage. And I want it to be ascending, not descending as it is by default. So that when I retrieve discount category, I return discount category, I run it, and now I have, it's not easy to see, order by sales discount percentage. Okay, I have for 0%, 0 with no discount. For 1%, I have multiple values. These are probably very, very close. Low discount, but for each possible value of discount percentage, I have only one category. Now, this table works fine. I have the same value multiple times. That is probably because of some rounding that is happening. So let me fix the percentage. We can go in discount percentage in the calculated column and round this division to the second decimal place. So that if I run again my query, now I have 0, 1, 2, 3. That is much more readable. And besides, I also have a smaller number of values. So I can now take this code, copy it, go in my model, and here I can create a new table that I call, let me see how I called it, discount category expanded. Discount category expanded, where I just pasted the entire piece of code. And I also get rid of the order by, because that is not only not useful, but even not supported. When I hit enter, now I have this discount category table expanded that is visible beside here. You see that I have all the values of discount percentage, discount code, discount category, and the discount percentage coming from the other table. And I can use this discount percentage column to build a relationship. That's exactly what I'm doing. Let's do that in a new diagram. We have sales, we have discount category expanded, and I can build a relationship between discount percentage and discount percentage. That's a many-to-one, single, yep, everything works fine. Now I have a limited many-to-one relationship between a table that is stored in the local vertical continent and a table that is in the direct query remote data island. Now, before we move further, just think for a second about this query. I have created a calculated column in sales in the remote island. This is actually a calculated column that will be computed on the fly for each query. But I'm using this column to create a calculated table that is now stored in the local vertical continent. And finally, I build a relationship with a calculated column that is actually computed every time and a table in the local vertical continent. No matter what, this query will never be wholesale. It needs to be executed by the local engine and the remote engine working together. So let's see what happens if we run a query. Now, what I need to do is go on this report, and instead of slicing by discount category, the calculated column in sales, I slice it by discount category in the local model. I place it here and it's not working because I should not use discount category. I need to use discount category expanded. Let's place this on the rows. And now you see I have my result. It's not sorted the right way because I forgot to sort discount category by discount code. Now I have no discount, low discount, medium discount, and high discount. And this is going to be a retail query. Let me check the code. We use view, we launch the performance analyzer, start recording, refresh the visuals, and now we have the code. Let me copy the query. We go in DAX Studio, we paste the code, both DAX and direct query, and let's evaluate this code. Now, the beginning is the very same as before. The only relevant difference is that now I'm grouping by discount category expanded. That is a table in the local vertical continent, and I'm computing sales amount that is a measure executed by the remote engine. The important difference starts here, starting from direct query. So let me copy all this code, paste it in a different window so we can format it. And let's inspect the code. You see that now we have the definition of a table that uses the union of two variables, the definition of another table, then we have the column discount percentage, and then this set of variables. Now, it's not time right now to discuss the detail of these variables, but you see that the query is very, very different from what we had previously. Besides, if we execute this query, let me remove the second one that is only for the grand total. This is the direct query executed by the remote server. And you see that in the entire code of the query, there are no references to the discount category descriptions, to the names that we actually see in the result. If I run this query and I look at the result, you see that the result contains two columns named value and then the numbers. Now, the numbers that you see here are the same numbers that you see here. We have 4896 here, which happen to be the same value present here. So the values are being computed by the remote engine, but the remote engine does not return the description of the categories because it doesn't know them. The query executed by the local engine only sends a query to the server to retrieve data structure that will that will be later merged with the local table, and at this point the local engine will produce the final result. So this is actually a query that is a mixture of both vertical queries and local queries. You can also see the same if we get rid out of the original query of all the direct query queries. So this is now the query executed by the local engine. We enable server timings, and then we run the query against the local engine. You see that the result of the query is grouping by discount category. But when we look at the server timings, you see that there is a mixture of local vertical queries and direct query queries in the same execution. So that is a retail query. As you have seen, depending on the complexity of the code, you end up with composite model in having only wholesale query or retail queries. The concept of wholesale is important because calculated columns need to be wholesale. But besides that, there are also semantic differences in the code, in the DAX code, when it is executed wholesale or retail. This is just an introductory video, so what we want to highlight, what we wanted to show was only the difference between wholesale and retail. But stay tuned, because there are a lot more information to learn about wholesale and retail. When it comes to composite models, when it comes to using all selected or optimized in DAX code, the difference between wholesale and retail becomes extremely important. Enjoy DAX!